Yeah, hi. Good morning. Sorry, good afternoon. Okay, so this is the first session for revision session of end term. So, as we have mentioned that in the previous sessions that syllabus for end term exam is from week 3 to week 11 mainly. Okay, and generally we says that the syllabus is till week 11, so that we complete syllabus. But generally first 2 weeks content we not gives in the end term exam. So you can consider that week 3 to week 11. Okay, so this is the syllabus for final term exam. Am I audible? Can anyone confirm?
Good
Yes,
afternoon,
sir,
sir.
you're audible.
Yes, sir.
Okay,
You
okay,
are
fine.
audible.
Okay, okay, thanks. Yeah, okay. So now we have divided the this revision session into 3 sessions. So and we will discuss three weeks like till week 11. Okay, so today I'll cover from week 3 to week 5. Then next is week 7, 6 to 9, then 11. Oh, last session. So Thursday will be the last session for this term. Okay, and yeah, so like weightage of the each week will remain approx equal. Okay, so like week 3 to week 11, approx equal weightage will be there for the questions. And so just prepare well for these part. And we have also released the mock, so you can solve these questions. So mock is released with the deadline, so complete it before the deadline, and you can verify your answer on the that final day. And we will also discuss these questions in our mock sessions, okay, which are related to the corresponding week. So okay, uh, now OPP exam is already done. How was your OPP exam?
So good.
Okay, this OPP 2 na, OPP second.
Yes,
Okay,
sir.
and result is also out, I think. Hmm.
Yes, it's out.
Okay, good. Okay, so let's start with the big three content and recap the things. So let me share my screen. Okay, I quickly recap through the notes which we have already shared in the complement supplementary content, and what are the important things you can focus that we will discuss today. So yeah, so big three basically we are starting from the C programming concepts, and what are the basic structure, basic operator, and expression. Okay, so that is required for any language. So C programming structure, what is the structure we have for the preprocessor? I hope you have done lots of programming. Now you got these things very clear. So what are these hash include std.h, or what are these pi? Okay, so these are very basic, but we will discuss about the some basic important things that are important for final exam. Okay, so this main thing is okay, global declaration that will come in the that in the detail in the week 5 content. So I'm not going that in much detail. So statement expression, these are very basics. Written statement. I'm coming to the operator. Okay, so keyword basically, so this is also very important. You should know the basic keywords. What are the keywords generally Python language used? Why this is important? Because sometimes, suppose if any questions asked like which one is the correct variable format, okay, variable name, valid variable names. Okay, so sometimes some keyword is also mentioned in that set. Okay, so in the options. So like this case CASE, okay, so this is a keyword in the C programming language, and which is used inside the switch case. So you cannot use this keyword as a like variable, okay, in the C. So some rules are there for the variable naming and any function naming like this, but we cannot use the keyword which is already defined in the programming language. So just you can go through these keywords once, or you have mostly used also in your programming. So you know many of them, but again you can remember some of these. Okay, so now next is variable in C. So this is very important. What are variables? So variable are named storage location in the computer memory. This is just like a label of the memory address. Okay, we cannot recognize remember the memory address, so we just give the label to that. Okay, so label we can give any name, any type of name which we can remember, and that points to that memory location. So these are variables. So variable declaration, you know that first we define this data type, and then variable name. Okay, so what type of that data will that variable will point actually. Okay, so variable initialization in the count equal to 0. So initialization means when we initialize when we assign the first value to the variable. So that is just like initialization. Naming rule, yeah, this is very important. So they can include letters, digits, and underscore. So this is the very common uh, things, so that can we can use inside the variable name. Okay, letters we can use, so either uppercase or lowercase we can use. Okay, and digits 0 to 9 and underscore, so this extra character. And they must start with the letter or underscore, so means we cannot start any variable name with the numeric value. Okay, variable names are case sensitive, so here you can see my where and my where, both are my where, but here this is the capital V. Okay, so both are different actually. Okay, so because case are different. So C has reserved keyword that cannot be used as a variable name. So this is the we cannot use this keyword as a variable name. So these are some rules that you should remember. So some questions may be generated on this. Okay. Now data type in C. So what are the common data types? So integer, int, we have seen float. Okay. So here some typical 4 bytes in most system. So that's typical size is also given here, so you can remember this also. Double takes 8 bytes. Okay, and what is the meaning of char takes single byte? Okay, these are bools which we have not discussed in the course. So bool generally we used as a like integer return 0 is considered as a false, and another any value other than 0 is considered as a true. Okay, so if in the conditional statement we have any positive or negative value, that will be considered as a true. Okay, if we have 0 in the conditional statement, then that will be considered as a false. So this is the one thing. Custom data type. So this we have already seen. Type diff. Type diff is just like if you want to define the type. So that I think is discussed in week 8. Then where we have discussed this struct union, these things. Okay, we can define the type for any structure or union. So that is used for this type diff. Modifiers and data types, so these are just like some modifier of the data types. Okay, so we can just update the size. Suppose if we want to store the integer value, but we don't require a 4 byte for that. Okay, and we have very small range to store, so that we can use this like sort. Okay, so used to reduce the storage size for integer. So sort is the modification for the integer, so that will take only 2 byte. Okay, and long, if we want to store a big value, then we can increase the size of integer. Okay, so suppose we want to store very big value, so that we can assign with long. Okay, so long. And sign and unsigned is also there, so that is also modified. So if we have the unsigned int, we can only store the unsigned integer value. Otherwise signed int can store the negative value also. Constant also is there one, so that cannot be modified later after the sign. Okay, now operators. So these are very basic operators, arithmetic operators, or all you know that basic arithmetic. Now relational operator. So this is equal to not equal to, less than, greater than. This is also fine. And logical operator. So this is very important. Here from many questions is actually can be generated. Okay, so these are logical operator, and where the that actually comes between the conditions. Okay, where two or three, any number of conditions that generally we use. So logical means hmm. So first suppose condition 1 we have C1 and C2. Okay, so two condition we have. So generally how this actually solve the complete expression of condition. So suppose condition is maybe that contains the relational operator. Okay, so that less than, greater than, we are comparing something. So here C1 condition is and the C2 condition, and we have the requirement where we want to perform some action where when the both conditions are true. Okay, so this type of requirement generally comes in our program solution. So some place we have two condition to verify, and if both are true, then we will perform our task. If any of them is not true, then we will not perform our task. Okay, like this. So for this type of situation, we will use AND operators. Okay, so suppose we are using AND operator. This is the double sign. So here, if both condition are true, then overall output. Okay, so here I am writing the overall output for this expression, C1 and C2. Then only this output will be true for this complete expression. Okay, now if any expression is any condition is false. Okay, like this, suppose this first one is false, second one is true, output will be still false. Okay, overall output is false. Now true, and then false, then still false, and both are false. So these are only four possibility between two conditions. So we have all false. So this is the AND logic functionality. And here with the compiler, there is one important thing here. So this is the working, but how the compiler actually works? Because compiler knows that in the AND case, if both are true, then only output will be true. So compiler utilize this feature also. So what happened when suppose C1 and C2 this condition is coming in the expression. So if a compiler will check the first condition first, okay. So the C1 will be checked first. If C1 is false, okay, C1 is false, then compiler will not check the remaining second expression, because if first is false, output will definitely will be false. Okay, so no need to evaluate the second condition. So because of that, this part will not evaluate overall. Okay, so if any like operation is there, like increment, decrement, and something is there, that will not be actually execute. So this part on right side part completely ignored. Okay, if first condition is false, and output will be false. So sometimes what happen? Suppose basic question I'm mentioning, a equal to like 0 and b equal to like 1. Okay, and I'm saying that we have the condition a, okay, and like uh, plus plus and b minus minus, suppose. Okay, so like this, and we are checking this, and we are just storing this value into c. And we are asking that what is the value of a, b, c after executing complete this part. Okay, so now you see this is post increment. So what is the meaning of post increment? I'll come on that also. So post increment is generally, first we will use this expression, what is the current expression in the, what is the value of current operator in the current expression. After that we will increment this. Okay, so now, and this is the end expression, so compiler will check this expression first and will read this value. Okay, after reading this value, then that value will be used for this conditional statement, and after that this increment will be happen. So currently a equal to 0. Okay, so now a equal to 0, and 0 will be considered as a false. Okay, now false, so first condition is false, second this is and expression, so now second part will overall be ignored here. Okay, but this expression is now, this part is completely done, left part is completely done, so a will be considered as a 0, so false will, it will consider as a false, and overall expression will also become a false. Okay, so now c will be also become a 0. Okay, but this increment will happen after evaluating this expression. This increment will also be performed post increment, so a will become 1, but this side, this will be ignored completely. Okay, so this decrement will not be happening, so b will still remain 1. So this type of tricky or logical question generally comes in competitive exam also. Okay, not only end term. So if you're giving any exam for where the C course is there, so you will see this type of questions. So this type of logical question. Okay, so how this increment decrement is happen, and how the behavior of this AND operation. Okay, so now this is the things for AND. and let's come to the or. So suppose the same thing, C1, C2, and output. Okay, the overall output. Now or. So this operator, when you required a situation where any of the condition is true, then you will perform the task. Okay, so either this one or either like other one. Okay, so if either C1 is correct, either C2 is correct, okay, or true, okay, so you overall output will be true. So in this situation we use the or operator. So like there are four situations, so like true, and this is the operator for this, so true and true, so overall output is true. And true or false, okay, still output is true. And false and true, still output true. Okay, and false, then only false. Okay, so this is the situation for with or. If any condition is true, output will be true. So here what happened, same things with the previous. If compiler is checking the first condition, if first condition is true, then output will be true, doesn't matter what is the second condition. So here if compiler is evaluating the first condition and that is true, so compiler will ignore the remaining part, evaluate. Okay, that part will not be evaluate. Okay, first condition is true, overall output will become true without checking the second condition, without evaluating. Okay, if first condition is false, then only second condition will be evaluate. Okay, so this is the things with the or operator. Okay, so now the same type of questions, a equal to 0 and b equal to 1, and like now we have the suppose okay, so now pre-increment I am taking, so with or and same things. Okay, so b like minus minus, suppose this is the there. So what is the overall output in here? So here you can see a equal to 0. Now this is the pre operator, pre-increment operator. Okay, so before using this value a in this expression, we will increment first this, then we will use this value in the current expression. So a value is 0. Now a will increment by 1, then it become 1, and 1 means true overall. Okay, so now first part is become true, then second part no need to check, and this part will be ignored completely. Overall output is also become true for this. So now C will become 1 and A is also become 1, but B is still 1. Okay, so if our compiler is moving to the next second part, then only this value will be changed. Suppose if this pre-increment is not there. Okay, so in this case C will now first value is false. Okay, equal to 0, and now A is actually false. This first condition is false. Then compiler will move to the second condition, and that will evaluate that this is the 1 currently. Okay, so that will consider as a true. So C will become 1, and after evaluating this expression, but decrement will happen. Okay, so that B will also reduce to 1, so A is still 0 and B will also become 0 for this type of situation. Okay, so this is very common. There are many possible questions on this like concepts on this operator and pre-increment and post-increment. So this is the or, and a logical not is just like it to change the condition output. Okay, so suppose if you have condition C1, and just to mention logical not, so if C1 is returning true, so overall output will become false. Okay, if C1 is returning false, overall output will become true, like this. Okay, so this is a logical operator, and now moves to the assignment operator. So this is also easy. So assignment is just assigning a value. So some sort things like we want to write like a, sorry, suppose a equal to a plus 10, so we can also write a plus equal to 10. Okay, like this. Okay, so this is just like a sort thing. So plus minus equal to division, all things are the same. Okay, so this is equivalent. Okay, so this is the pre-increment decrement. So I have already mentioned that. What is this meaning actually? So in the expression, hmm, so I'm again just repeating quickly. Hmm. Suppose if we have a equal to 10 and b equal to 20, and we are writing like uh, a plus plus and here like plus and minus minus b. Okay, like this we are writing. Okay, so how this expression will be calculated? So here c equal to a, so this is post increment, so current value of a is 10, so this value will be used in this expression. Okay, and plus plus now this is pre increment, so we will use the value after increment decrement. Okay, so minus minus b is just a 19, so this now become a expression, so c will become 29. Okay, but this increment will also be happen, but after the after using that value. So this means a value will become after increment 11, and b value will also decremented by 1, so that 19. So this is the effect of pre-increment and decrements. Pre-increment means use the value after pre-increment or pre-decrement. Okay, and post increment means use the current value and then increment or decrement. So this is the only meaning of this pre increment and post increment. So this is very important. Okay, key point expression. So expression is okay, fine. Yeah, this operator precedence, you can just remember this thing. So what is the meaning of operator precedence? So associativity also. So some this very common order is given here. So this is the highest precedence parenthesis. Then unary operator is considered as a next precedent multiplication. So what are written in the same line actually that have the same precedence. Then we use the associativity. If our expression have the same like preference precedence, sorry, same precedence, then we use the associativity. How that expression will be evaluated? So multiplication, division or modulo, all these consider as a same precedence. Addition, subtraction will consider as the same precedence. Okay, so like this, this is the order. You can one see this one. So, okay, and associativity is just like a if we have the expression like this. So hmm, suppose a plus b minus c plus and d. Okay, suppose this expression is there and you are assigning this value to x. So here this expression plus minus plus, all these are the addition and subtraction. So all these have the same precedence. Okay, so in this case we then associativity comes. So which part will actually evaluate first? So here we associate it with the same like precedence operator is left to right. Okay, so this plus minus plus that will be evaluated from left to right. So first this part will be execute. Okay, suppose this is giving like a result p 1. Okay, so now p minus 1 c plus d. Then this part will be evaluated. So this suppose this is giving p1 1 and like plus d, and then this part will be given. Okay, so in this way this evaluation will be executed. So most of the operators are left to right associativity, but equal thing is actually right to left associativity. So mhm. Suppose if for expression is written like this, a equal to b equal to c equal to d equal to 5. Okay, so here all operator are equal. Okay, so and this assignment operator. So here actually this expression will be solved from right to left. So first this value will be assigned to D, and now D become 5. So D will assign to C. So C become 5, then B, then like this. Okay. So this associativity is, you can remember that equal has the right to left associativity. So other basic operation, this addition, multiplication, like this has the left to right associativity. Okay, so you can see left to right associativity, addition, arithmetic operation, subtraction, multiplication, division, modulo, all these have the left to right, and logical operator also. But right to left, you can see this is the one example. Okay, equal sign. This has the right to left associativity. Now another thing is input output, scanf, all these you know. Okay, so I'm not going to deep in this. So this is the week third. So just recap practice on this part. Now comes to the week four. Hmm. Yeah. So week four, we have used the control statement. Control statement means that control the flow of executions. Okay. So generally, the flow of execution is always from top to bottom. Means if we have like a statement, okay, if we have written the statements in the program, so that what are the statement is written on the first, that will execute, then second, then third, then fourth, then fifth, like this. Okay, this is the order. But sometimes according to our logics or our that program requirement, so we need to repeat something, okay, we need to skip some things, so some steps based on the conditions, so we require something, some control actually on the flow of this. So because of that, this control statement is used. So first is very important is conditional statement in C. So conditional statement means we will check some condition, then we will decide which part is should we execute actually after the condition. So if statement, and if the logical diagram for this is, you can see this. Okay, if condition is there, and then we will check the condition. If condition is true, so we are coming to true side, and if condition is false, then we are moving to false block. Okay, so generally we have the blocks for execution, and we execute the one particular block that is satisfied by the condition. Okay, so this is a simple statement. If condition is true, then we will only execute this block. Okay, if this is not true, then we will not execute, we will skip this. So this is the if statement, if else statement. So if else means if we have the two possible block. Okay, so if the condition is true, then first block, then if condition is false, then another block. So we have used the if else things. Okay, so if it's true, we are moving to this body of if. Okay, if it is false, then body of else. So this is the like syntax for this. Okay, now same we can move continue this chain for the long, okay, with the more conditions. Suppose if we have more than one condition to check, and based on that we want to decide what we need to do. Like if we want to distribute the grade for the marks. Okay, and we have the range for each grade. Okay, so suppose we want to give the S grade those who have the 90 to 100 marks. Okay, now we want to give the A grade those who have the 80 to 89 marks. So like this we have multiple range, okay, for different grades. So in that case we have to use this if else, this type of chain. Okay, so like if first condition we will check, if that is true, we will enter inside this, otherwise we will check the second condition. So in this way we can make a chain, and only the one block will be executed in this. Okay, so if this in this chain, if any first block is executed, remaining actually will not be considered, and that will be ignored. So any one of the block will execute. So this is like a conditional, and another way to do this is switch statement. Okay, so switch statement, here uh, we have some expression inside the switch. Okay, and based on the value of switch we define the case that contains that value, that is the possible result of the expression of switch. And if any value is matched with the any case, so only that case block will be executed. Okay, but here some important and tricky thing is, here we require a break if we want to only execute the that case body. Okay, we have to break that, we have to use the break. If we are not using the break, so flow will actually move to the next block. Okay, next case block. Okay, so like this is very important point for this. So you can see if expression here, suppose case value 1, value 2, value 3, these are the possible value of this expression. Okay, and this expression may be anything like addition or something, increment, decrement, anything, but that will return a single value, and that value we have defined the case. Okay, and suppose if our output of this expression is matched with this value, okay, this value. So now our flow will move to this statements. Okay, what statement is written inside this case, that will move to here. Okay, if we have the break statement inside this is okay, so now we will enter to the break and our flow will directly move to the end. Okay, now our flow will directly move to the end and it will skip all the remaining statements of another case. But if this, suppose if this break is not there in our statement, then flow will directly jump to the statement of another case. Okay, and then again it will check this break is there or not. If not there, then it will directly move to the next statement of a next case. Okay, so this is the way. If at any point if break is found, then our control will be terminated. Okay, will be out of this switch case. So this is very important. So if suppose switch case structure is given and this break statement is not there, so remaining statement will also be executed if that also not contain the break. Okay, so this is the flow control for the switch case. Okay, so like this expression is given, I think some example here you can see. So here we are passing the day equal to 2. Okay, so day equal to 2 to directly case 2 is now a match. Okay, with the value case 2, and only Tuesday will print. And using this break statement, this only Tuesday will be the output for this. But suppose if we removed all the break inside this, so what will happen? Our case 2 will be matched first and Tuesday will be print, but after Tuesday, control will be moved to the next statement, Wednesday will also be print, and then this default will also be print other day. Okay, if break is not there, suppose if break is there inside the Wednesday, okay, so only Tuesday and Wednesday will print, then break will happen and our out control will be out of this. So this is the here use of break. Okay, so this is the flow of like switch statement, so we can use according to our requirement. So sometimes some so this is also useful if we remove the break, so that is also the possible use case. Sometimes suppose if we want to start with the case and we want to perform all the actions which are coming after that, so then this break is not required. Okay, so just keep this thing in mind. So according to this situation you have to give the answer, and this is also important. Okay, break things. Hmm. So now nested conditional statement. Nested means multiple one inside another. Okay, so that is nested thing. So if condition is coming, so here you can see another if condition is there inside the outer one. So this is just a nested things. And next comes to the loop. So loop is required when we want to perform the same task multiple times. Okay, so we want to repeat the same task for some number of times. So this is the for loop, and for loop flow is like this. So we have the first initialization, then we check the condition. If condition is true, we enter inside the body and we perform the statements, and we update our conditional variable value and then again check the condition. Okay, and we repeat this cycle until our condition become false. Okay, and then we will loop the things. So here this is the initialization point. So this first value inside the, you can see in the for this condition bracket, we use basically three parts are there. Okay, so first part is actually a initialization part, second part is a like conditional part. Okay, and third part is a update variable. So we initialize something, we can initialize one variable, we can initialize two variable, more than one also. And this is the this step only executes one time. Okay, this part, this will not always execute. Okay, this is only one time execution. But after that we our control is actually check this condition. So that is depends using this variables. Okay, some variables. If this condition is true, control is moved to the body and execute the body. After that this part is updated. Okay, your loop variable is updated, either increment, decrement, or by any value. Okay, then again this condition is checked, then if it is true, again enter into the body, then again update the variable. Like this cycle will run. Okay, So if at any point if condition is false, your control will move to the outside of this. Okay, so this is the way of this for loop. Now you can see this equal to I. This part will only execute one time, but after that we will check this condition. So 1 is less than 5, yes, so this will print. Then 1 will be increment by 1, so 2. Now 2 is less than 5, yes, again will print like this. Okay, so this is the way of loop execution. So now nested loop things are the same. So that is not okay. Yeah, another type of loop is while loop. So while is also very similar, but we actually externally perform the initialization for the while loop variable, and then we check the condition, and the same things, condition is true, perform the statement, and inside the statement actually we update the our variable control condition variable. Okay, and in this way we repeat these things. At any point if false is there, then we will exit. So here initialization happens outside of this loop, update variable happens inside the body. So then this become a loop, and the same thing we can perform with the for loop also. So here you can see, so I is initialized outside of this, then we are checking the condition. Now I is incremented inside the body itself, and this loop will run. Okay, at any point its condition is false, we will exit. Now this is the while loop, and so yeah, this is some condition where this actually should we terminate. Always take care of this, like do not run like a infinite loop. Okay, so do while loop is the another thing. Do while means first at least one time we will execute the body of loop. Okay, then we will check the condition. Okay, normal while loop, if we will first check the condition, then only we will enter into the body. But here at least one time body will be executed without checking the condition. So here you can see we are entering into the statement first, then we are checking condition. If condition is true, then we are repeating the same body. Okay, so only the difference is there. So do while looks like this. So first statement will be executed, then condition will check. If it is true, then it will repeat the things. So this is the change. And other than this, all things are nested loop. So one loop another inside the another loop. I hope you have seen many like code like this. So where we are using some 2D metrics or something, we require this type of nested loop. Okay, so one outer loop, inside that another loop. Okay, so this is called as a nested loop. So break, continue, go to statements. Yeah, this is important. So break is used to break the loop, nearest loop, we will say. Okay, not the all loops. So what loop is the nearest loop for that break, that will stop. Okay, without executing the remaining part. So this loop is running like this, and if I become 5, this break will execute, and all the remaining iteration actually will not be executed, and your control will come directly out of this. Okay, so this is the nearest loop. Suppose if your break statement is comes under here, like inside this loop, so only nearest this loop will be break. Okay, not the outer loop. So either while loop you can break, for loop you can break, using the break statement. Continue statement is if you want to skip some part. Okay, if you want to skip the remaining part and you want to move to the next iteration without executing the remaining part. Okay, so here you can see if I is even, then continue. Okay, so this print statement will not be performed actually. Okay, and so means this code will actually skip the even numbers. If I value is odd, then this print will happen, but if I is equal to even, so this continue will move to directly to the next iteration without executing the remaining part of this code. So this is continue. Go to statement is also used, but you have to use the label for that. So like this label you can write, and this is just like a checkpoint. Okay, so you have mentioned the checkpoint and you have given the name for that start. At any point you can jump to that point to execute. And okay, so here you can see go to start, and start that will jump to this statement, and all the statement from this point will execute again. So this is just like a specific point where you want to jump. Okay, so you can jump at any point. You can jump not only the loop, okay, you can jump to the initial of the program also by this. So this is the goto, and this is like not very important. So a single line statement, multiple line statements. I hope you know that. Okay. So this is all the control statement, and next comes to the like function. Yeah. So function, yeah, this is important. So basic function things you should know. So what is function? Function in C programming are block of code that perform a specific task. So generally, writing suppose if you want to perform the same type of task, and that required multiple time in our code. So instead writing the same code multiple time in our program, just write one time and give the name for that block, and you can use multiple time. Okay, by just calling that block. So by function, reusability, modularity, readability, maintainability, these are the some benefits for the function. And like predefined functions are there. So these are the function which is already built in C libraries, okay, or external libraries like printf, scanf, mallocf, freef. So all these are function actually where you are looking this round bracket with the name. All these are functions, and that is defined already in the standard library, and that is performing some task that will take some parameters or argument and will return something, okay, as per the definition of this. So external library function, yeah, standard library, external library, which are not comes under the C library, but that is defined by some external, okay, things. User defined. So that is the function which you can define. Okay, so any function you have defined, that is called as a user defined function. So like if you want to perform some addition tasks, okay, so you can create a block of the code that will perform only this addition task or multiply all etc. So this is the structure. Like return type, you have to mention if you are if you want to return something from the function, okay, you have to mention the what type of value will return, so that type you have to define. Then function name, and then you have to define the how much or how many parameters you required for that function, so that is you have to define. So what type of value you want to uh, pass as a argument. So you have to give the variable name as well as the type of that variable name. Okay, so this is the set type of overall structure, function definition, then body and return things. If you're not required to return anything, just mention as a void. Okay, so like this, the all pointers are given. Okay, and we call like this. So here you can see we have mentioned. So this function just like a declaration. Okay, we are just telling to the compiler we have the one function which these actually data types. Okay, so function name is add. It return type is integer. We have two variables int a, int b, or you can also skip this variable name at the time of declaration. Just mention int. Okay, so this is just like a declaration of the function. Okay, after that you can define the function. So what will function will do actually. Okay, so you can just define the function. So that add int a, int b, you are just taking two value in the a and b, and you are using that and return something. And you can call this from anywhere. If because it is defined globally, you can call this from any out other function. So result equal to add, like, okay, so we are calling this add 5 comma 3 and returning something, so that return value will be passed to this assignment operator. So this is the function. So function, now different way to pass parameter to the function. So yeah, this is thing. So call by value. Okay, so we are suppose passing the value only or variable name. Okay, that is just pass the value, and that value is stored into the function variables. But call by reference. So instead of passing the value or data, we are passing the memory address. Okay, where is actually data is stored. So we are passing the address, and that is called as a call by reference. Okay, so instead of passing value, we will pass the memory address, and we will use that memory address to read or write the value in our function. So that is called as a call by reference. Okay, like this. So here you can see increment x. So here we have this num equal to 5. Now in this increment function, we are passing the address, memory address of this num, not the value 5. Okay, and that memory address we will read the value and increment the value on the same place memory. So now that can be reflect also in the main function. Otherwise the function use their local variables. Okay, main function is different. So but still here we can act, we can our update will reflect actually, because we have done the operation on memory place, not the local variables. So recursion is another type of function. So if function call itself inside the body, so that is called as a recursion. So recursion should have some basic things inside the body. First is base case should be defined. Base case means the case when we will not call the same function again, means the stopping situation. Okay, we will not call again. Okay, and the recursive case means where actually the condition where we will call the same function again. Okay, so that part, that is called where we are calling the same function again, that is the recursive part. Base part is actually where we will stop the process. Okay, the situation for the stopping. Stack memory is actually just like a memory where the all these variables are stores. Okay, so like stack recursion is just we are calling the same function, but that each call actually will generate a new stack to store the variable for that local function. So stack memory is used, and like factorial calculation you can see. uh, So here factorial function basic definition is given. So you can see how we are calling this. So this is called as a base case. Okay, so n equal to 0 and n equal to 1. So this at any point if our n becomes 0 or 1, so we will stop the process, only return 1. But if otherwise, we will call the same function again. Okay, so this is the recursive part and this is the base part. So base case should always be there, otherwise your code will actually call like a till the recursive depth. Okay, and that will create a problem. So base case should be there, and also recursive case should also have some this type of condition where your input data should be moved to the base case. Okay, so after some iteration or some recursive calls, your process should be reached to the base case. Okay, so that condition should be there in your function definition. Okay, so this is the base case recursive case things. So type of recursion is direct recursion. So direct recursion means we are calling the uh, same function inside the same body. Okay, so this is a direct recursion, but indirect recursion is also there. So like one function is calling to the another function and another function is calling to the first function. Okay, so like here we have two function, int or even and odd. So from even we are calling the odd function, and from odd we are calling the even function. So this is also a like a recursive things, but not direct. Okay, this is a indirect recursion. And scope in C programming, yeah, this is important. So scope means the how where from we can access the data, and if any data is defined. So global scope, generally we write outside of any function in the common just common area, and that value can be accessed from any part of this code. Okay, any function also. Local scope is just like a if we have defined some variable inside the any function, so that variable is just like a local variable for that. Suppose this is a function and we have defined one variable this, so this can be accessed only inside this function, not we cannot access this from outside of this function. So this is local for this. Block scope is also there. So block scope is which defined inside some block. So block means you can see this conditional statement is given, and the block of this condition statement which is coming inside this curly braces. So if any variable which is defined inside this int y equal to 10, that cannot be accessed outside of this block also. Okay, so this is the block level scope. Okay, this x equal to 5 is defined outside of this, so that can be accessed inside of this if condition, but anything is defined declared inside this block that cannot be accessed outside of this. So yeah, this is the scope things for the like variables or any variables. Okay, now this is the big 5 and big 6. pointer. Okay, so let me just discuss pointer basics and endianness. So pointer is another type of variable. So that pointer that is to the memory address only. Okay, that is stored memory address for another variables. So this is the pointer, and declaration initialization like this. So we define the data type means what. Okay, so this is the variable name, pointer name. So this will store the address of another variable. So what is the type of that variable? Okay, so that data type we have to define here, data type. Okay, and this asterisk is the representation of this is a pointer, actually not a simple variable. Okay, so pointer only can store the address. So here you can see we define, and address we can fetch through this AND operator sign. Okay, if we put this AND operator sign with any variable, so that will return actually address of that variable, memory address of that variable. So we can assign any address into the pointer like this. So in testing ptr is equal to AND x, so address of this x will be assigned to this ptr. Dereferencing pointer means we want to access the value of that pointer. So that is the similar type of this. So at the time of declaration we use this asterisk sign. Okay, at the time of declaration of pointer, but later if we want if we use this inside the expression, so that is used considered as a dereferencing. Okay, so here like this is written here. Okay, so asterisk ptr, so this will return the value of value on that address. Okay, and that value will be assigned to y. Okay, so this expression is written like this. So here this is a pointer ptr that is storing the x, but pointer is also a variable. Okay, so that also required some memory space. Okay, where that is storing the other address of another variable. So means this pointer also has the address. Okay, that pointer address. So this is the type of pointer to pointer. Okay, so pointer of another pointer. ptr2 double asterisk means this ptr2 is a pointer, but that contains the address of another pointer. Okay, so pointer of pointer we can see, because of that we are using double asterisk. Okay, so you can see we are assigning the address of another pointer ptr. So and the same dereferencing we can use like this. So pointer of function, pointer and function. So we can pass the pointer inside the function, and we have mentioned this. We can directly access the memory value from the memory, and we can update directly. So null pointer is just like a pointer that doesn't point to any valid memory address. Okay, so we generally assign the null value for that. Okay, so suppose if we have created the pointer but that not contain the any memory address, so we can initially assign that with the null value. Otherwise maybe garbage value may be there. So this is the null pointer. Endianness is just how the actually memory is represent for the data. Okay, so here there are two type of endianness there. So little endian and big endian. Okay, refers to the order of which bytes are arranged in memory to represent the data. So here little endian representation, suppose consider the 4-byte integer, this one. Okay, so this is the 4-byte integer value and memory address. So how the or memory address byte will be assigned to this? Okay, so suppose memory address like 100, this will be assigned. So little endian means the last value, this lsv value. Okay, lsv value will be assigned to the smaller address value. Okay, so 100 we are assigning this 78, then 101 is assigning to the next two digit 44 byte. Okay, so for okay, so next will be assigned to the next big address. So means we are starting with the small address, and that small address will be assigned to the lsv first, and big address will be assigned to the msp side. Okay, so and the reverse order of this is called as a big endian representation. So this type of two endianness are there, memory representation are there for the data, so that you can remember these things. So how this the order, this is also important. Okay, so just remember these things. Okay, and this is the only things. Data alignment is not much important. So mm, Okay, I am not adding this because this will create a confusion. Okay, this is not, data alignment is not important. So this is the things till week 6. I have mentioned week 6. So let me just take, if you have any query, you can ask. Otherwise, let me move to the mock questions related to this and try to solve that. Any query till this week 5 and week 6 content which we have discussed?
No, sir.
Okay, these are very basics. I hope you have understand now because you have done
Yes, sir.
too many things. Okay, so this now first question in the mock. Okay, now you can tell me what will be the answer for this first question. Anyone? We have solved this. A equal to 10, then bracket is started, then int a equal to 30 again. So what will be the output of this code? And this question is belongs to the scope topic. Anyone answer for this? So here you can see block, actually this bracket is started and this is ending here. So this is just like a one block. Okay. Inside this block we are declaring a variable int a equal to 30, and we are printing also the value. So this here, this part actually, so print statement will use the local value for this. Okay, so what is the local value for this block a that will used? Okay, so 30 will come from this inner part. Okay, but this cannot be accessed from outside, so outside variable a is actually different. So this is will be considered into the second print statement. So 10 value will be come from the second. Okay, so 10. So value of a is like 30 and 10. This should be correct. Second option. Okay. And here you can see I have mentioned this. Here pre-increment was also there, and also break statement is also not there. Okay, so this is the concept which I mentioned. So here we are starting with a equal to 2. Okay. Now this is a pre-increment. Means first we will increment the value, then we will use inside the switch. So that become 3. Okay, a is now become 3. Now we are entering inside this case 3. So 3, now a equal to a into 4. Okay, so 3 into 4. Now it become 12. Now there is no break statement. Next expression will solve. So a equal to 12 divided by 2. Now it is 6. Again, no break is there. So next expression will be solved. So a equal to a multiply a. Okay, so this 6 into 6 means 36. So final a value is 36. So this is the correct answer for this. So which of the following statement is true regarding function in C? So which a function is a block of code which is only executed when it is invoked. It is true. Okay, so function is only executed when we call the function. Okay, then otherwise that is not actually done. So this is true. A function can invoke multiple times in the same program. So this is also true because
Yes,
we
sir.
can call any number of times the function. So that will also true. A function cannot accept more than 2 parameters. So there is no condition like this. Okay, so we can pass any number of parameters. So this is not true. A function cannot call itself. So this is totally out of the definition of function. Okay, so this is not correct. So only A and B is first and second is correct.
So what is the answer for the first one?
First one answer is B. This value of A is 10, 30 and value of A is 10.
The value of A is 30 and value of A is 10.
Huh.
Thank you, sir.
Okay. Second correct is this 36. And okay. So what will be the output of this above C program? So here you can see this is okay. Okay, this is just like a simple function. We are not using any pointer like this. So this is also checking the scope things. So we are passing a equal to 5, b equal to 3 value into the function. Okay, so that fun ab. So that value will be passed to a and b of this function, ever one. So the here a and b are actually different from the main function a and b. So that are storing the same value because that value is passed to the function. Now we are swapping this. So this is just like a swapping. Okay, so we are changing the value inside the function. So a will become 5 and b will become 3. But that swapping is only happening with the function variable. Okay, so this function local variable fun. So if you are printing this output in the main function, so that function will only we print the local function, local variable value a and b. So that is still 5 and 3. Okay, so 5 and 3 output will become. So swapping is happen with the local variable of fun. So that will not reflect here. Okay, because the both variables are different variables and take the different memory. So output will be 5 and 3 for this. Like this. Which of the following function compute and returns the factorial of a given positive integer num? So here, okay, recursive function is there. Yeah, recursive is also there. So which one will correctly solve? Okay, factorial. So factorial is simple definition. Suppose if 5 is there, so 5 into 4 into 3 into 2 into 1 should be output. So is this happening in the code? So suppose first program, so we are passing suppose 5. Okay, so now we are assigning res equal to 1 while num is greater than equal to 0. Okay, this okay. Now res equal to divided by sorry, multiply by num. So res is okay. So we are starting with 5. Yeah, 5 into 1. Next time it will reduce. So num will be reduced, and then like 4 into 5. Then next time 3 into 20, like this. Okay. So this is like looking like correct because we are multiplying the same way. So 5 into 4, then 3 into 2 into 1 because this condition is running greater than 0, and finally we will return the output. So option 1 is looking correct. Second option, res equal to 1, num is okay. So this is just like an infinite condition. Because here we are not decrementing num, so this condition will always be true and our code will enter into the infinite loop. Okay, so this is not correct. So so next third option, so this is the if num is equal to 0, return 1. Okay, otherwise return num into fact of num minus. Okay, so this is fine because base case is clearly defined. So if we are reaching to num equal to 0, so means we are performing this num into fact of num minus 1. So like this, we are first time num equal to 5, so multiply by fact and num minus 1. So that is actually 4. Okay. Now this call will actually return 4 multiply fact 3. Now this will return 3 multiply fact 2. Okay. Now this will 2 into fact 1. And this will return 1 into fact 0. Now here 0 is there, so 0 when we are coming is returning 1. Okay, so 1. So 1 into 1 into 2 into 3 into 4 into 5. So you will get a correct answer. So this is also correct. And the next, yeah. So here only the change is return 0. So this is the problematic because if we will return 0 from this position, so 0 into 1 will become 0, then 0 all will
The
become
whole
0.
code will become zero. Yes.
So this is not correct. So A and C is the correct code for the factorial here. So in C, which of the following are valid operation on pointer variables? So this is pointer arithmetic. We'll discuss in week 7. So that is not discussed. So still divide one pointer variable by another pointer variable. So divide operation is not supported. So that is not a variable. Comparing two pointer variables for equality. So this is okay. Okay. Comparing pointer, we can compare the pointers value. So this is valid. Increment, decrement a pointer variable. Yeah, this is also fine. Multiply two pointer variable, this is not correct. Okay, so dividing, multiply, this type of is not a arithmetic operation for pointer variables. Okay, so this is again pointing. Consider the C program, that is one, and for given option, identify the appropriate statement in place missing code. If the output of the code is 1, select all that apply. Okay, we are finally printing the value A. Okay, so A value is printing, so that is actually 1. Now you see when this value will come actually 1. So A equal to 1, and now pointer B is containing the address of A. Okay, and now okay, A is equal to 1. If we are writing A equal to pointer B, so means what is the meaning of this? A equal to what is the value at B? So that is still 1, correct? So asterisk B means reference. Okay, dereferencing we are doing for B, and B is a pointer actually of A. Same. So same one value will be assigned to A, and then that one will be print for this. Okay, so this is correct. Asterisk A equal to B. Here this is not true because it will give the like syntax error, because asterisk A is not possible because A is a simple variable. We cannot use this asterisk sign for that. Okay, now asterisk. So this is asterisk and address of A. Okay, so this means address of A. This is fine. Equal to yeah, this location we are storing the value of B. Oh, same things. Okay, so currently the value of B is actually 1, so that is assigned to the address of A. Yeah, this will work. Okay, what we are doing, we are storing the one value at the address of A, so that will work actually. So this is okay. Again, this is wrong. Okay, asterisk A, we cannot write like this. Okay, so asterisk can be used with the address. This is simple variable, so this is wrong. So A and C is correct for this. Okay. Again, this is also a pointer arithmetic. So in the following C code, what does the function fun do? So here we have the function x equal to 7. We are passing the address of x, and we are printing the x value. Okay, so what we are doing, so we are taking the pointer ptr that is getting the address of x. Now we are incrementing the value of ptr. Okay, so this is just like a dereferencing sign, means we are pointing to the memory address of that ptr, and we are incrementing the value of that. Okay, what value is it storing? So here you can see it increment the value pointed by the ptr by 2. So this is not correct because this is just a single increment. So it adds 1 to the value pointed by the pointed to by ptr. So this is fine. It modifies the address of ptr incorrect, and it does not modify. Okay, so B option is correct. So that is only added the one value, incrementing the one. Okay, so this is correct. And you can see this is same related to the your NDNS problem. Consider integer variable like this 89209899, and this is the starting address 128. So which one is the little endian? So little endian is actually
The first
start with
one.
the small address and so take the 99 value first. Okay, little endian. Hmm. And next that is 98, then 12 is 20. So first option is looking correct according to the definition. So 120, 99, 98, 20. This first one is the correct because see this LSV value will be stored at the smaller address. Okay, and MSC will be stored at the last address. So first is correct. Okay, now array is coming, so that we will discuss in the next Tuesday session. So that is from like week 6 to week 8. So okay, if you have any query, or you can solve this by your own. Okay, and you can also check. Okay, any query, anyone?
No, sir.
Okay, so that's the content for today revision session, and we will meet on Tuesday for the next week content, like week 6 to week 8. We'll recap that. Okay, if there is no query, then we can close the things. Okay, thanks everyone. Bye.
Okay, sir.